All right, looking at example 3, we have x minus 4 to the 2/3 minus 9 equals 16. And I can't say this is that much different from the last couple examples, except maybe there's a couple more steps, but looks pretty similar. So what we're trying to do here is we're trying to, again, isolate, get x, not just x by itself. Well, eventually we are, but we're trying to get the rational exponent term here, or the radical expression there by itself, right? Because then we can get rid of that exponent. And so this one here, we're going to add 9 to both sides. That would give us x minus 4 to the 2/3 equals 25. And as we just did, x minus 4 to the 2/3, if I want to get rid of that exponent, I'm going to raise it to the reciprocal. Raise this whole thing to the 3/2 and 3/2 on the other side. So that's going to get rid of, these two things will cancel, because exponent properties tell us that we will multiply those, and therefore we would get an exponent of 1. So this would just give us x minus 4 all raised to the 1, or just x minus 4, equals, and now we have 25 to the 3/2. And you should know what 25 to the 3/2 is without using a calculator, because we know how rational exponents work. 25 to the 3/2 is the same as taking a square root of 25, because that number's on the bottom, right? And then cubing that. This is the same. 25 to the 3/2 is the exact same as root 25 all cubed. So square root of 25, of course, is 5, and 5 cubed is 125. So I know that 25 to the 3/2 is 125, so therefore my answer here, x minus 4, is 125, and therefore x is 129 as an answer. All right, a handful of questions here to practice. Go ahead and pause the video and we'll work through them. Okay, 3 questions. All right. This first one, divide by -2, and this actually looks like the practice problem that you did just in that last video. So I'm just realizing that. So a repeat here, but so we would get x to the 3/4 equals 8, and then you would raise everything to the 4/3. 4/3 here. That would give you x equals 8 to the 4/3, which is the same thing as a cube root of 8 all to the 4th. And as we said before, you can punch that in your calculator, 8 to the 4/3, but you should also be able to rewrite this because we have those skills. Cube root of 8 is 2, and 2 to the 4th is 16. So this one is 16. Second one. X minus 5 raised to the 5/3 equals 243. So we're going to raise this one to the reciprocal. Raise this one to 3/5, because the original exponent there is 5/3. So therefore we're going to also raise 243 to the 3/5. That's going to give us, these exponents then will cancel off, and we'll get x minus 5 equals 243 to the 3/5. Well, 243 to the 3/5, that would be a 5th root of 243, and then all cubed. The 5th root of 243 is 3, and 3 cubed is 27. So this is 27. We have x minus 5 equals 27. And if we add 5 to both sides, then we end with x equals 32 as my answer. Last one, over here, x plus 2 to the 1/3 plus 3 equals 7. First, I would subtract 3 from everything so that we can, again, isolate this radical expression here. So I have x plus 2 to the 1/2 equals 4. And then I'm going to square both sides. Now note, this is the same thing. You could rewrite this x plus 2 as the square root of x plus 2. It's the same thing because it's being raised to the 1/2. You could rewrite all these problems as a actual root or radical term. You don't have to, but just kind of take note of that. I'm gonna square both sides to get rid of that 1/2. So this would then become x plus 2 by itself equals 4 squared, which is 16. And therefore we can subtract 2 and get x equals 14 for that problem. All right, so looking at the last type of problem. So there are these things called extraneous solutions that we've talked about in other equations that we've solved. An extraneous solution is, I would call this an apparent solution to an equation that doesn't satisfy the original equation. And at the end of the day, it's just not a solution. So we can put that in here. This is not a solution. So what happens there is you take a look at the equation, you solve the equation algebraically, and you don't break any algebraic rules, but you get some answers that are not quite, that don't either make sense in the problem, or when you take that number and you plug it back into the original equation, it just doesn't satisfy it. It doesn't actually make the equation true. So we have these things called extraneous solutions, and let me show you one of those. So example 4, and this will be the last one that we do. So you have this problem that says check for extraneous solutions. It says solve this and check for extraneous solutions. So if you were looking at this problem and you were to do this algebraically, of course, looking at this problem right here, it might actually be easy to just kind of guess and check this, by the way. But just to show you this one, if I wanted to solve this, this was a little tricky one because we have x's on both sides of this equation. So I would like to get this x and kind of connect it with this, but I can't really do that because one's inside of a square root and the other one's not. But what I can still do is get rid of this square root on the left-hand side. So since this is a square root, or it's raised to the 1/2, I can raise that side to the 2, square the left-hand side, and then therefore I would have to square the right-hand side. So that would give me on the left x minus 6, and on the right I would have to expand that out. I'd have x minus 8 times x minus 8. I'd have to multiply that out. So that would give me x squared, and I'm not going to show every step here because we've done so much of that, but that'd be x squared minus 16x plus 64 if you were to multiply that out. And then on the left we get x minus 6. All right, so now we're in a situation where if we look at this problem, we have a quadratic equation that we need to solve, like we did in the warm-up. So go back to your quadratic equation solving, and that means we have to get this into standard form. That means we have to get everything to one side and then make it equal to 0. So that's what I'm going to do here. I'm going to get everything to the right hand side. I'm going to subtract this x, and I'm going to add the 6 so that the left hand side is 0. So I'm going to subtract x on this side, and I'm going to add 6 so that I have 0 equals x squared minus 17x plus 70. So I'm going to solve this quadratic. Again, I'm left with that situation of, can I factor this, or should I just use the quadratic formula? This one is factorable, and if you don't notice something's factorable right away, you can definitely use a quadratic, but this one you can tell is, if you've done a little bit of factoring, you can tell this one is factorable because what multiplies up to 70 and also adds up to negative 17? Like, that's going to work out, right? So what multiplies up to 70 and adds up to negative 17? The answer is 10 times 7. 10 times 7, or negative 10 times negative 7 would do the trick there. So this factoring works out just fine. X minus 10 and x minus 7 is my factoring. So when we finish this and solve it, that means that these two factors, zero product property, that means my answers here, x equals 10 and x equals 7, are my solutions. However, one of them could be extraneous, or both of them could be extraneous. And so what we'd have to do here is we'd have to check our answers. So let's check our answers, because it says to check for extraneous solutions. So if I say x equals 10, that's one of my answers. Well, let's just see if that one is correct, right? If I plug in 10 into that equation, I get the square root of 4 equals 2, and that one seems to work out just fine. 10 is good, but what about 7? So if I plug in 7, I get the square root of 7 minus 6 equals 7 minus 8. So we're saying the square root of 1 equals -1. And so this is not true in the context of what we're doing. The square root of 1, since we're only using the plus square root, we're not saying plus or minus here, and that's why the extraneous solution is popping up. We're only using what we call the principal square root. This 7 is extraneous. So 7 is not an answer. So I'm going to put a little cross through it, and I'm just going to label this as extraneous right there. So 10 is really my only true solution there, not 7. Even though we did everything correctly, 7 is an extraneous solution.